Today's lesson will be over section 1.6, polynomial and radical equations. A polynomial equation is a result of setting two polynomials equal to each other. Technically, in all of the other lessons that we've done this semester, we have been working with polynomial equations, but we can classify them as linear because our x's in linear equations all have the same criteria. Their exponent has to be 1. Same thing with quadratic. We can classify those polynomial equations as quadratic because its highest exponent of x is 2. Today when we're talking about polynomial equations, we're talking about ones that have a degree bigger than 2 or exponents of 3, 4, 5, etc. A radical equation is just that. It's an equation that has a radical in it. The concepts that it takes for us to solve both of these equations we have already done. We are going to solve polynomial equations, and remember when I say polynomial equations, I'm talking about x cubes, x to the fourth, and so on. We're going to solve these using the same exact factoring method that we learned for section 1.5, which was quadratic equations. The only difference, however, comes in this method, okay? So if you remember, when we're factoring, we have to make sure one side is set equal to 0 so that we know the true value of our terms so that we make sure we are factoring them correctly. If you remember in quadratics, when we factored, we wanted to factor our equation down to linear factors. We don't need to do that anymore. When we are factoring, our factors need to be linear or quadratic. Now that we know how to solve quadratic equations, we don't need to split our factors down to linear. In fact, most of these, it's not possible to get all of our factors to be linear, okay? Once we have linear or quadratic factors, we'll set those factors equal to 0 so that we can solve those equations for x. Remember, these equations are either going to be linear, that's the first type of equation, or quadratic. When we solve quadratic, remember we have 3 methods: factoring, square root property, and the quadratic formula. Once you get to this, you'll have the option as to which one you want to use. Okay, so let's look at one. 4x to the fourth equals 12x squared. This is considered to be polynomial because our highest exponential term is 4. Okay, if it was only a 2, it would be still polynomial, but it would be a quadratic polynomial equation. So we want to make one side equal to 0, so we're going to subtract the 12x squared from both sides. That makes my right side 0, and it makes my left side 4x to the fourth minus 12x squared. Now we're going to factor this polynomial. Remember, we want our factors to be linear or quadratic. This is a 2-term polynomial. Difference of 2 squares, it is not, because 12 is not a perfect square. Sorry about my dog barking in the background. So the only form of factoring we can do is the greatest common factor. The greatest common factor of these 2 terms is 4x squared. When I take that out, I'm left with x squared minus 3. So we have 2 factors here. Both of them have an x squared. That means this is quadratic and this is quadratic. Since they fit our criteria, we can set those factors equal to 0, and we can use our quadratic methods to solve these 2 equations. I'm going to use the square root property here, which says my x squared has to equal the number. So to get my square term by itself, I have to divide by 4. 0 divided by 4 is 0. Once x squared equals numbers, I take the square root of both sides, and by property, x equals a positive or negative square root of our number. However, in this case, since our number is 0, there is no positive or negative, it is just simply 0. I'm going to use the square root property on this one as well. So x squared equals the number 3. You can take the square root of both sides, and x equals positive or negative 3. Since the radical 3 does not reduce, I cannot do anything else. My x answers are 0 and plus or minus the square root of 3. Okay, here's another one. Again, my highest exponent is 3, so it now classifies as a polynomial equation, not linear or quadratic. So again, we need to get 8x over to the other side and 12 over to the other side. So I get 2x cubed plus 3x squared minus 8x minus 12. Now this is a 4-term polynomial. That means that eliminates the methods that we know of chart, which is a trinomial, box, which is a trinomial, difference of two squares, which is 2 terms. So the only method we know so far that we can use to factor this would be GCF. However, the GCF of these 4 terms is 1. So we have a 4-term polynomial whose GCF equals 1. We don't have a method that can factor this right now, so I'm going to teach you a new one. It is called factor by grouping. Okay, so when we factor by grouping, first thing we're going to do is group terms 1 and 2 and 3 and 4. So I'm going to go over here and I'm going to put parentheses around terms 1 and 2 and around terms 3 and 4. Notice that this sign between terms 2 and 3 I did not put into the grouping. We will use it later. Okay. Step 2, factor each group. So I'm going to use GCF to factor these. In my first grouping, I have an x squared as a factor of 2 terms. I'm left with 2x plus 3. I'm going to carry this minus sign down. Okay, and I'm going to think of 8x and 12. Well, that has a greatest common factor of 4. Because of this subtraction, that now means this is a negative 4 that I've taken out. And negative 4 times 2x gives me my negative 8x. Negative 4 times positive 3, negative 4 times positive 3 will give me negative 12. If you have done factor by grouping correctly, you should notice that your polynomial factor in each of your groupings is the same. If it's not, you've done something incorrect and you need to go back. Okay? We're now going to look at this as 2 separate groups. We have factored each group. And now we're going to factor the groups again. We're going to factor the common polynomial factor out of each factored group. Okay, so if both groups has a 2x plus 3 in common, I can factor that 2x plus 3 out. And remember, when we take something out, whatever factors are left, we leave behind it. So the common factor of 2x plus 3 goes here. I'm left with an x squared from the first grouping and a minus 4 from the second grouping. Okay, this is called factor by grouping. Again, it can only be done when we have 4 terms whose GCF is 1. Follow these steps. As long as you can factor properly, you should be good. Now this is a linear factor, so I can set that one equal to 0. This is a quadratic factor. I can set that equal to 0. Linear, I'm going to subtract 3 and divide by 2. X equals negative 3 over 2. This one is quadratic. I could do this one of 3 ways. Since this is the difference of 2 squares, I could factor it into x plus 2 and x minus 2. Since x squared can equal 4, I can use the square root property. If x squared equals 4, then by property, x equals a positive or negative square root of 4, which equals positive or negative 2. Okay, I would get the same answer if I factored it. X plus 2 and x minus 2 is going to give me positive or negative 2 for x. If I use the quadratic formula, my a value would be 1, my b value, since there is no x, would be 0, and my c would be negative 4. Okay, so those are the 2 types of polynomial equations and factoring you're going to need to do. Radical equations actually turn into linear or quadratic equations, but we have to do something to them to get it to that point. Okay, so the first thing we're going to do is isolate our radical expression. Find it, make sure nothing else is being multiplied, divided, added, subtracted to that radical. So if there's something is, you need to use your inverse operations to get it to the other side. Once that radical is by itself, we can square both sides because square rooting a square, or square rooting a radical, sorry, are opposites. Square both sides, not square root. If we square a square root, they are opposites. Then we will, in step 3, solve our equations for x. However, these solutions for x are going to be the solutions to a linear or quadratic equation. They are not solutions to the radical equation because we got rid of the radical. They're solutions to the linear or quadratic equation that's left. So our fourth step is to check our solutions in the original equation to figure out which one works. Okay, so we're going to plug our x's that we get here into our original radical equation. This is the step that solves the radical equation. If we don't check it, we haven't solved the radical equation yet. Okay, so here's our first one. Square root of 20 minus 8x equals x. So our entire left side is the radical. I'm not multiplying anything to it, dividing anything from it, adding or subtracting. My radical is already by itself, so I don't need to do step 1. So I can go to step 2, which says to square both sides. Squaring a square root are inverses, so that will eliminate the radical. So I'll be left with 20 minus 8x. And when I square x on the other side, I get x squared. That makes this a quadratic equation because I have the highest exponent is 2, which makes it a squared term. I'm not going to be able to use the square root property because the square root property says x squared equals numbers. Well, x squared is already here. It will never equal just numbers. It equals a number and a variable term, so I can't use that. I could use factoring. I could use the quadratic formula. In both of those steps, one side has to equal 0. So I'll get x squared plus 8x minus 20. From here, you can decide if you want to factor it or use the quadratic formula. I'm going to factor this because x plus 10 and x minus 2 are my factors that will give me this. I use the chart method. 10 times negative 2 is negative 20. 10 plus negative 2 is positive 8. So this is quadratic. So in quadratic, remember we want our factors to be linear. They are. So when I set them equal to 0 and solve, x could be negative 10 and x could be positive 2. Now I say they could be because right now these are solutions to this. To get those, we solve this quadratic equation. We need to solve the radical equation. So we need to check these two answers into the square root of 20 minus 8x equals x. Now this radical is already here. So we know when a radical is there that whatever sign is in front of it tells us which square root they want, the positive or the negative one. Since there's no negative sign in front of this, I want the positive square root. So if I'm checking negative 10, I'm going to get 20 minus 8 times negative 10 has to equal negative 10. That gives me the square root of 20 plus 80, which gives me the square root of 100. And since I want the positive square root, that is 10. 10 does not equal negative 10. So this is an extraneous solution. It is not a solution to our radical equation. It will not work. Okay? So now we need to check 2. 20 minus 8 times 2 has to equal, in this case, x, which is 2. So we get 20 minus 16, which is the square root of 4, and the positive square root of 4 is 2. Since 2 equals 2, x equals 2 is our solution. Let's look at one more here. This one, here's my radical. It is not all alone, so I need to subtract this x. When I do that, I get negative square root of x plus 11 equals 1 minus x. But when we're talking about expressions with variables and numbers, we always want the variable to be first. So this minus x, I'm going to move in front, the positive 1 behind it. This negative right here means there's a negative 1 that is a multiplier, so I need to divide by negative 1. So I get the square root of x plus 11 equals x minus 1. Now my radical's alone. Now I can square it, and I will square the difference of x minus 1. Squaring a square root makes that square root disappear, and when I square a difference, I have to multiply that difference by itself. So I get x plus 11 equals x squared minus 2x plus 1. This is again quadratic. Because I have x terms, I'm going to have to use factoring or quadratic formula, which means one side has to equal 0. So I'm going to subtract x and subtract 11. So 0 equals x squared minus 3x minus 10. Again, from here, you can factor or use the quadratic formula. We get x minus 5 and x plus 2. Those numbers will multiply to give us negative 10 and add to give us negative 3. And when we set those linear factors equal to 0, we get that x could be 5, or x could be negative 2. And remember, to solve the equation, we have to check those into the original radical equation to figure out which one, if any, will work. Okay, so we're going to check 5 first. So 5 minus the square root of 5 plus 11, that has to equal 1. So I get 5 minus the square root of 16. Minus square root of 16 means minus 4. And 5 minus 4 is 1. So x equals 5 will be a solution. Just because this one works doesn't mean that one won't. It is a possibility that both of them will work, or one of them, or it could be that none of them work. So we get negative 2 minus the square root of negative 2 plus 11. Again, that has to equal 1. We get negative 2 minus the square root of 9 equals 1. Negative 2 minus the square root of 9 is minus 3. And negative 2 minus 3 is negative 5. Negative 5 does not equal negative 1. So negative 2 is not a solution. If you have any questions over this, please let me know. Let me find my record button. Sorry about that. Okay, I will send you an email with your homework for all of this.